The name of this lesson is Pythagorean theorem, and this is probably the most important theorem that we use in geometry because it is so useful and you use it so often. And so we want to be able to apply the Pythagorean theorem to right triangles, as well as we will find right triangles within quadrilaterals and other triangles. You'll see right triangles a lot in geometry. So here's some definitions. The first term here is just a right triangle. Okay, familiar with those? A right triangle is a triangle that has one angle that measures 90 degrees. And then in this picture here, we see a right triangle that has a label of A and B on two sides of the triangle. Those are called the legs of the triangle. The legs of a right triangle are the sides of the triangle that form the 90-degree angle. And then C is the longest side of the triangle, and it is opposite the 90-degree angle, and that is called the hypotenuse. Okay, so let's look at some examples. Okay, the Pythagorean theorem, this is really important. It describes a relationship among the lengths of the sides of a right triangle. That's all it is. So here's some different ways that it can be represented. First, algebraically, and the one that most people remembered is a squared plus b squared is equal to c squared. That is describing a relationship between the lengths of the sides of this right triangle, where a and b are the legs and c is the hypotenuse. So in words, in any right triangle, the sum of the squares of the lengths of the legs. So this here, a squared plus b squared, is the sum of the squares of the lengths of the legs. It's equal to the square of the length of the hypotenuse, which is c squared. In the geometric model on the right, you can see that we have this right triangle, and what they've done is they've literally drawn squares off the sides. So in this A side here, if the side length of A was 4 squared is 16, so the area of that square would be 16. On B, if the length of the side of B was 2, well, B squared is 2 squared is 4, so that would be 4. And so A squared plus B squared, so the square, this square here that is labeled C, would be 16 plus 4, which is 20. So that would be C squared. All right, let's look at a couple examples. Okay, first, again, they restate the Pythagorean theorem. A squared plus b squared is equal to c squared. And then we have a diagram at the right. Two of the three squares are labeled with their areas. The three squares are to form a right triangle when joined at their vertices. One side of each of the two shaded squares will be the legs. So like this would make the legs. And then the side of the unshaded square would be the hypotenuse. So in other words, here's my right triangle. And so these sides are A and B, and that side would be C. Well, they have given us the square of A is 25, and they gave us that the square of B is 36. So what would be the area of the unshaded square? Well, you would just add 25 and 36, and it would be 61 centimeters squared. Okay, let's look at another example. Okay, in example 2, we're going to use the measurements here to find a missing measurement. It says when 2 of 3 sides of a right triangle are known, the third side can be found using Pythagorean theorem and determine the value of x. So here, we're given the lengths of, for a squared plus b squared is equal to c squared, we're given the lengths of a and b. And then this side over here labeled x would be c. So we can say 3 squared plus 7 squared is equal to c squared. So 9 plus 49 is equal to c squared, and c squared is equal to 58. Okay, but we don't want to know what c squared is, we want c. So if we take the square root of c squared, we get c, and so we would take the square root of 58. And then for now, if you put that into your calculator, you're going to get a decimal. So this is the exact answer, the square root of 58. And that's how I prefer that you would leave it right now. Again, I'm going to go ahead and put that in my calculator and see that that is approximately 7.6. Okay? But this is an approximate answer, approximately equal to 7.6. The exact answer is the square root of 58. And when we get back from Christmas break, we're going to spend some time with simplifying radicals and talking about that a little bit more. But please pause the video right now and try and solve for x in part B. Okay, I have a rectangle. I know opposite sides are the same measure. So I have that, and I want to use a squared plus b squared is equal to c squared, where a and b are 7 and 24. So 7 squared plus 24 squared is equal to c squared. 7 squared is 49. 24 squared is 576. And that's equal to c squared. And if you add 576 and 49, you'll get 625 is equal to c squared. So we take the square root of c squared, which is c, and the square root of 625. Now, the square root of 625 is actually a perfect square, and it is 25. Okay? Okay, before we start with example 3, we are going to talk a little bit. I see that the length of this side is 5 to the square root of 2. And so, well, let's just go ahead and set it up. So here's a square, and all the sides are the same, so we can call them all x. If this one's x, that's x. So using a squared plus b squared, well, we could call a squared plus b squared is equal to c squared. Well, a and b are both x, so we can say x squared plus x squared is equal to 5 to the square root of 2 squared. X squared plus x squared is 2x squared. 5 to the square root of 2 squared. You can use your calculator for that, but you'll probably need to use double parentheses. But let me show you by hand. When we say 5 to the square root of 2 squared, that's 5 to the square root of 2 times 5 to the square root of 2. And what you do is you're going to multiply what's outside the square root together. So 5 times 5, and that's 25. And then that's multiplied by the square root of 2 times the square root of 2. And you can use your calculator to check, but the square root of 2 times the square root of 2 is 2. And so we'll have 2x squared equals 50. Divide both sides by 2. X squared equals 25. So x is equal to the square root of 25, which is 5. All right, let's look at the quick check. We have, again, a radical for c. Okay, so again, just follow the rules the same. This is going to be a, this is going to be b, and this is going to be c. So I have 6 squared plus x squared is equal to 6 times the square root of 2 squared. So I have 36 plus x squared is equal to, and again, if you put double parentheses and put that in your calculator, you can get the answer. Or you can say 6 to the square root of 2 times 6 to the square root of 2. So you're going to multiply 6 times 6, which is 36. You're going to multiply the square root of 2 times the square root of 2, which is 2. And you get 72. So now we will subtract 36 from both sides. I'm going to do it in my calculator. Do not make a mistake. 72 minus 36 is, okay, that's what I thought, but I was a little confused for a second. 36, and so the square root of 36 is 6. So x is equal to 6. That picture is not drawn to scale. That's why it kind of confused me a little bit. But yes, the answer is 6. Okay, let's look at example 4. Now on this one, x is over here, and so we have to look. What you can see is that we have that's a trapezoid. We'll talk about those pretty soon. But you can create a rectangle here. Okay, so create a rectangle. There's your right angle. So opposite sides are the same. So if this is 5, this is 5, and this is 8. And so now 11 minus 5 is 6. So now we can use our right triangle. 6 squared plus 8 squared is equal to c squared, or x squared. 36 plus 64 is equal to c squared. 100 is equal to c squared. So c is equal to the square root of 100, which is 10. Okay. So I'm going to scroll up, and again, you should please pause the video and try and solve this one. Okay, so I worked it out. Hopefully you paused and did it yourself. This isn't drawn to scale again, so be careful, because this side is 10, so this side is 10. So 34 minus 10 is 24. So we have a measurement of 24, x, and 25. And so x squared plus 24 squared is equal to 25 squared. And if you finish solving it, you'll get x is equal to 7. Okay. All right. A pool table measures 4 feet by 8 feet. What is the distance to the nearest tenth of a foot from one corner pocket to the opposite corner pocket? So again, this is just going to be a right triangle problem. When they say to the nearest tenth, that means use your calculator to get an approximate answer. So this is 8 and 4. So 8 squared plus 4 squared is equal to c squared. 64 plus 16 is equal to c squared. 80 is equal to c squared. So the exact answer is the square root of 80, but they say they want an approximate answer, so you put that in your calculator, and the square root of 80 is approximately 8.9. Okay, in the quick check, find the length of the diagonal of a rectangle with length 12 and width 5. So here they don't give you a picture, so you just need to draw your own picture. And so you have a rectangle with the length 12 and the width 5. Okay, here's our right triangle, and we want to find C, the diagonal. So 5 squared plus 12 squared is equal to C squared. 25 plus 144 is equal to C squared. 169 is equal to C squared. So the square root of C squared is C, and the square root of 169 is 13. So the length of the diagonal is 13. Okay, I'm running out of time on the video, so I'm going to pause here and we'll do the last examples on a second video.